All right, welcome everyone. Welcome to our webinar today. Today we are talking about Octopus Deploy and Clear Measure Q&A with advanced topics around database deployments. And just logistically real quick, if some of you could respond in the chat that the audio is coming through loud and clear, that would be awesome as we get started here. And I'm here with Paul Stovall, the CEO and founder of Octopus Deploy, Deployment Badass. And you're muted, sir.
Hey, morning, everybody. Well, morning for me, afternoon for most of you, I imagine.
All right, thank you for the chat. We're coming through loud and clear. I appreciate that. So a few logistics right before we get into the Q&A. The first one's on you, Paul.
Yeah, so we'd love your questions during this webinar. It makes it so much more fun and interactive. One of the challenges with Zoom chat is that people ask questions here, they disappear at the end of the webinar. We only have an hour. At the end of that, though, we'll stick around on we have a public Slack channel that you can join. We'll stick around on there. If you've asked a question that we haven't got to, we'll make sure we answer it at the end of the webinar. So if you go to that link, octopus.com/Slack, that'll give you the information you need to join, and then come into the webinar channel and ask questions there. If you do ask them on Zoom, we'll try and answer them here too. But if we don't get around to them, we won't get that opportunity to answer them here.
All right. So the agenda that we're going to go through is here. But before we jump into it, we have a little poll, and so the poll should have popped up now. And the question is, how are you managing your database deployments currently? And we love your feedback. We have a mountain of people on this webinar, and we're really excited with the amount of interest across the industry and just the sheer number of people. So we should have a lively chat over on the Slack channel. And you might have to if this is the first time going onto the Octopus Deploy webinar Slack channel, you might have to go to your email and accept that invitation just to get over there. But please do to have that on the side as a Slack, as a back channel chat. So the responses are coming in with the poll, and please, we'd love it if everyone responded there. Looks like we have some of you in every category, but we do have a lot of manual and semi-manual responses. Good. Appreciate you all putting in your responses. Those are super helpful for context as we go through these questions here.
Yeah, I'm loving the number of people with scripts that are already pre-prepared that they run manually, because they're halfway there, right?
All right. Okay, and it looks like everyone is put in, so we're going to go ahead and end that polling and proceed here. All right, and you know what? We're going to share the results just so that you guys can see how this audience was polled, so we appreciate that there. All right, let's rock and roll.
That's very cool. That's impressive to me. I'd love to know, maybe in the chat, or if you pop something in the Zoom chat, sorry, the Slack chat, just about what's holding up being further along. If you're in that camp of doing things manually, what's the thing that's preventing you from automating them? If you're doing everything manually, what's preventing you from creating scripts? That way we can make sure we address it during this call.
All right.
So a lot of people are on this call. I imagine they're already using Octopus. They've already got some kind of deployment automation going on, but they're not deploying the database. And so there seems to be something very different about the database. People don't seem to have as much trouble automating things like IIS or Windows services. But when it comes to the database, we see when we work with our large customers, the database is always the thing they lag on. It's always the thing where there's some kind of manual process still in the way. Why do you think that is, Jeffrey? What's so different about the database?
Sure. Well, it is fundamentally different because whether it's a web application or an offline job or any kind of computing component of the application, the database has to maintain state of some kind, whereas the rest of the application just has to process things, and you could redeploy with something as simple as FTP, just a file copy, because you don't have to rely on something remaining there. You can destroy it all and just copy the files back over. So compute components, they don't have the state, and they can be, like I said, deployed and put back easily. That's why all the simple and trivial DevOps pipelines that you find on YouTube have a website, but they don't have any database. And then the demo is, hey, look how easy it is to configure automated deployments, because that's the easy part. Storage components, whether it's a relational database with SQL Server or whether it's a folder structure of PDF files, any kind of storage component must preserve data for years and years. You've got blob storage, table storage in Azure, that directory structure, any type of database, SQL Server, Oracle, Postgres, MySQL, relational or document database. Your deployment must cope with the data that's probably been there since before the word DevOps was coined back in 2010. I know some of you probably on this webinar have data that probably originated in the 80s or 90s. If you look at the original record, if it's an old database, or even if some COBOL systems have been ported to .NET. I know Micro Focus COBOL and some of those others have .NET adapting frameworks, and so the data is really old. But when it comes to software, the data is more likely to be the company asset rather than the code that operates on the data. And some of the data probably existed many years ago before the computer system in a file cabinet of some sort on paper before your company went through digitization. So at some point, the current applications will be replaced by different ones, but the data is going to live on and it'll continue to grow and change. So test environments are easier to manage by something you can drop and recreate databases and reload them. You can't do that really in UAT or staging where you're trying to preserve production-like data, and you definitely cannot do that in production environments where you're going to do a deploy, so you just drop and recreate the database. So you have to adapt the database. And there are a few factors that are the same, and then some that are different when you're designing the right deployment process. So let's look at those. Let's look at those here. So the schema or the structure is owned by the software system and should be exactly the same in every environment. Some of the data, if you look at this diagram on the screen, some of the data is architecturally part of your schema, and so it should be the same across environments. For example, if you have some standard lists that populate drop-down boxes, such as common name prefixes, if you had a drop-down Mr. and Mrs., etc., Ms., then, and of course, in Great Britain, you have master and mistress, but these are the same in every environment. It doesn't change in production. There's different type of data, and that type of data is configuration in nature, and it belongs to the environment itself. Just like some configuration is stored in XML or JSON files and poked in during the deployment, some of the configuration is stored as records in a relational database. Some systems have settings that could easily be stored in a configuration file, but they happen to reside in a database table just by choice. And in that case, that table is housing environment-specific configuration data, but it's really environment-specific configuration. And then there's data that's administrative data, without which the software doesn't do much. An example of that is user or customer or account header records. And with none of these, no user would be able to log in and use any of the software features. And then there's the rest of the data, which is user data, which is what you think of as the normal data that's constantly growing, constantly changing as people use the system. So that's 4 different types of records that happen to reside in the actual database, and we have to treat each type different in a deployment situation. So the database is very different. We have to consider all of these, and the schema from a design time or development time concern, the schema and the architectural the architectural and standard list type data, that's what we define in at development time before we even do a build, and then the rest of that data has to be managed along the pipeline, along deployment. So we have to be concerned with all of those as we move along, and that's the fairly long-winded version answer of that question. But um, this is a complementary diagram of what we've been talking about how the different types of data interoperate with each of the environments, and how Octopus Deploy can facilitate each one. For instance, the configuration data that should go in Octopus Deploy, or should be accessed by Octopus Deploy and then pushed into every environment, as well as the administrative data. And then for environment specific data sets that are not production data, Octopus Deploy should interact with those, and push those forward. So um, hope that helps there. All right, Paul, what is the normal status quo at clients before they have automated their database deployments?
Yeah, sure. So if you go to the next slide, it looks a little bit like this. So when we'll talk to customers, they'll be automating other things with Octopus, but this is still how the database changes. So developers, they're on a 2-week sprint or something, following an agile process. They're making changes to the application. As part of that, they're making changes to the schema. And along the way, hopefully they remember to capture the SQL script to make those changes somewhere. Typically, this happens kind of at the end of the sprint in a bit of a hurry. They put this together by trying to diff the database to work out what they've changed. Or maybe they've collected the script as time has gone by. And then they email it to the DBA. And so I used to do this prior to starting Octopus. I worked at a company where we did this. We would create this script and you would email it to the DBA, and you'd start your production deployment. You'd take some services offline or something, and then you would go and queue up behind the DBA and wait while they found your email. They opened Management Studio. They went to the correct environment. Hopefully, if this is a test deployment, they're not accidentally running it in production. And they go through this script line by line, and they select a line and they read it, and then they run it. Management Studio, it only runs the part that you select. And so they do this, and they work their way down the script, reading it, running it, muttering about how your SQL skills aren't as good as theirs. And that's kind of the process at a lot of companies that we see. And it's good in the sense that at least you have a script, and chances are you're going to run that same script in your next deployment. But there's also a big chance that something goes wrong. There's a really important aspect of that, which is that we do want DBAs involved in that process. They have a lot of responsibility around keeping the database up. We as developers have responsibility around changing things. And so we want them involved in that process, but they don't need to be the ones executing the change. So a lot of the philosophy within Octopus is that we want, whether it's release managers or DBAs, people should be able to see the process for doing something, and they should be able to see the information that's in there at an appropriate time to do a review, but not be the one that's depended on to be there in that very minute running it. Because, in this environment that I'm talking about, if that DBA wasn't around, just finding another DBA who even had access to run those things in production and was prepared to read this during the middle of a production deployment, if he had to go home or something and wasn't available, like, you just couldn't find anybody. You're very dependent on this one person at a very critical point in time. A much better process for this would be, this script exists in source control. Just like other changes to code, you send this to a DBA to review a pull request, or just say, here's my script, what do you think? You get that feedback ahead of time. And then the DBA isn't required to be there on the day to run these things. It's all been reviewed ahead of time. Any problems can be fixed ahead of time.
All right.
So Jeffrey, what does we're trying to remove the DBA from running these scripts, not necessarily from reviewing them, but what does that actually look like?
Sure. Great question. So with an application component, a compute component, we have some files that need to be copied and some configuration that needs to be poked into the XML or JSON files. And so let's back up and look at the architecture of a proven database deployment process. So if we look at this diagram, we can see in the Git repository, we have some particular types of assets that are important to be in the Git repository itself. Obviously, we have to have the application code, the .NET application, but we also have to have the database migration scripts. Now, there's a lot of tools these days that can do automated database migrations, and they all include code files that you run in series. Now, there are tools that operate on SQL files exclusively. On the commercial side, you have Redgate SQL Change Automation. On the free and open source side, in order of popularity, you have DBUp, which is the most popular, and then you have Roundhouse, and then you have AliSQL in declining popularity. But they all function in the same way, the same architectural premise about let's have a directory with a series of SQL files, and whatever's in the SQL files, we're just going to execute against the database if that file has not already been executed. And we'll look at that demo just in a little bit, but you need those actually in your Git repository. Even Entity Framework core migrations has code files that operate in series, but the natural way to do that is with C#. But architecturally, you add an additional code file. You need those in your Git repository. And so your migration tool is going to run those upon building of the software. And so in a continuous integration environment on the build server, the build is going to provision its environment. It either needs to create a database locally or get access to a database that is essentially blank, essentially empty. And it's going to execute the migration tool, and hence all the migration scripts, and build up that schema from scratch. So your continuous integration build does create the database schema from absolute scratch. And then it compiles your .NET code, and then it does unit testing and integration testing, which, by the way, your integration testing should include tests that cover the queries between your application and that database schema to ensure that the schema is in sync with the data access code, whether it's explicit data access code or if it's an object relational mapper. So any particular build time data sets that you have need to be version controlled along with the code. And then your build is going to execute release candidate packaging, which we'll look at a little bit later in the webinar, and make sure that everything is stamped with the appropriate versioning, and we use static analysis. There's static analysis available for .NET code as well as SQL code. This view here is, I know you can't read all the small words, that's fine, but this is an overview of a properly integrated pipeline where the build server is taken care of by Azure Pipelines, and then deployments are taken care of with Octopus Deploy. And this kind of has an assumption that we're also targeting Azure, but it doesn't change much if you're just targeting Windows servers. By the way, if anyone is interested in receiving the full laminated continuous delivery poster, let us know. We'd be happy to send you one. Just comment in the webinar Slack channel, and we'll make sure that you get that poster. We'll send the high-res PDF, and it's of a format where you could get it printed in the full 2-foot by 3-foot format and hang on the wall. So if you would like, this is just part of it. I know there's a lot of text on there, a lot of information, and I'll go over it. But if you'd like that poster, just go ahead and put in the Slack webinar channel that you'd like to have that, and we'll make sure you get it. But the first thing is we have a private build in the Git repository, and then we execute the continuous integration build. At the end of the continuous integration build, we package up all the application components and put it in our NuGet feed. We can push it to the NuGet feed, the NuGet server that's hosted by Octopus Deploy, or we can push it to another NuGet server like Azure DevOps has the Azure Artifacts, which also hosts NuGet. From a technical perspective, doesn't matter as long as it's in a NuGet feed, and we want to use the NuGet packaging. And by the way, Octopack wraps the regular NuGet tooling, and it overcomes some of the conventions, and packages that application component in the way that is suitable for immediate deployment. So you'll want to make sure that you're using Octopack. It's essentially octo.exe, which is an open source tool in order to package your application components. And then for deployment, and your database goes hand in hand. You have a single, this is important, folks. You have a single pipeline for your application and for the database that it owns. You have the same single pipeline. We build once, we deploy many. And so let's just simplify it a great deal. You have a web application, you have an offline job that just wakes up on a schedule and does something, and you have a SQL Server database. You have 3 components of your application that you need to deploy. And so you're going to have 3 NuGet packages, one for each independently deployed application. We deploy them at the same time, but they are 3 packages. And so we have 3 environments. Your pipeline is never going to have fewer than 3 environments. Everybody knows production. You have production data, you've got your production application, and then backing off from that, you have your pre-production. A lot of people call it UAT, a lot of people call it staging, but you've got that pre-production environment. And then there's another environment that some people have, some people don't. Our best name for it is the TDD environment, standing for test-driven development. And we give it that name because it is for automation only, no humans allowed on that environment. And as soon as a continuous integration build completes, we automatically provision that environment, we deploy to it, we recreate the database from scratch, recreate the application components from scratch, and then we execute our full system acceptance tests on there, which are going to make sure that the full application and the database work well together. And because if it doesn't, there's no use doing a pull request on our feature branch to get that code into master, because we know something's wrong. We know it's not going to deploy. We know it's not going to start up properly. We know it's not going to function properly. And so doing that, make sure that before we even do our pull request, before we even get those set of code changes over to our master branch, we make sure that we haven't messed up the database schema, or we haven't made the database schema differ in relationship with the application code. And we make sure that we don't ever waste one of our product owners' time or our stakeholders' time by deploying something to their UAT environment, and then they just call us up and says, hey man, it doesn't even work. Okay, so you're going to have no fewer than 3 environments when deploying the database and the application. And that first line automation environment, we are re-provisioning that entire database from scratch. With the next UAT environment, we are keeping the database in place, we're keeping the data in place, and we're executing an upgrade of the database schema by only executing the scripts that have not yet been run in that environment. And the tool is going to take care of that by looking at the history table that it maintains in the target database. So by doing that, if the last time we deployed to that environment, we had maybe 1 SQL script, which added maybe it only added 1 column to 1 database table. Well, great. The upgrade means we're only going to execute 1 file. But if we've got a lot of hardcore development going, and we have 10 database scripts, and somebody's been working on a new module, and we have 3 new tables, well, all of those SQL scripts have not been executed on that target database yet. And so all of those are going to be executed. And since they're all differential, it doesn't matter how many environments we have, the exact same database package is suitable for deploying to any target environment, because the history table in that database shows which have and have not been executed. And then when we execute to production, we know that we've executed the exact same process in several environments prior. So we don't have to ask our question, ask the team, hey, let's make sure that we know what we're doing with production, because we already know the database package that's going to be deployed. It's already been tested. And that's really important. So if we expand just the deployment portion of this diagram, you can see some of the details around it. And from an orchestration perspective, if you're already using a build server like Azure Pipelines or TeamCity or even Jenkins, you want to make sure that from an orchestration perspective, that your build server kind of has that orchestration responsibility, and it is taking the build number that it is sourcing, it's labeling every deployment package, those NuGet packages, with that version number, and then it's passing it and calling Octopus Deploy through the APIs, or maybe through the step template that Octopus provides for all of those build servers, and passing that build number so that the release number in Octopus Deploy is the exact same release number as the build number, so that all those versions tie in together, and you're not having to do any manual mapping of, oh, Octopus release version 456 corresponds with build version 123. You want to make sure that that number is exactly the same throughout the entire pipeline, and that you've integrated those tools appropriately. All right, and then the final, the final piece is this diagram of how that NuGet package actually gets it gets treated in Octopus Deploy. Octopus Deploy is going to drop and recreate the TDD environment. It's going to take what's in that package, which is essentially a zip file with a manifest. NuGet packages are zip files, and it's going to do those different things in each environment. We always load the user data test set in the test-driven environment, in the test-driven development environment. We do that sometimes, but only on demand with UAT, and then we don't do it in production. Okay. And by the way, these slides are going to be sent out to anyone that requests it, so you can get these diagrams as well. In Octopus Deploy, and this is the final part of that answer, in Octopus Deploy, the steps are really, really simple. The database step, we configure to grab the package, we open it up, and then this initialize database step is essentially running a post-deploy PowerShell file, which essentially just has the command line to whatever database migration tool that you're running. And that's pretty much it from an Octopus Deploy configuration standpoint. All right. And some of the, we'll show this a little more in the demo, but if you look in Visual Studio, this happens to be what you see with the DBUp tool, where in Visual Studio, all you have is a directory of SQL files. And Paul, there's some rules that we go through here. And you want to go through them?
Yeah, sure. So the first one is that every change to the database is scripted. Now, this sounds kind of easy to do. It's also easy to forget to do. For example, if you're using Azure SQL, it has a very handy tool where it will suggest indexes that you should add to your database. Those suggestions are great. Don't run them. Take them, put them in a script, save the script in source control, and then have it go through your process like everything else. That way, every environment ends up the same. You're not wondering why production is performing so differently to a test environment. So the first thing is to script every change. Now, the way you go about scripting those changes, there's kind of two main ways. One is to, when you're in Management Studio and you go to like a table in the editor, the UI, you can add a column or something. There's usually a button at the top to generate a script. So a lot of people will do that, take that script, check it into source control. If you're comfortable writing T-SQL, you can obviously write them yourself. And then there's tools like SQL Compare, which will compare changes done to two databases and generate a script for you. Those tools are very useful at dev time to work out what you've changed if you can't remember. I don't recommend them during a production deployment because they'll generate changes that kind of miss the nuance of exactly how you go about migrating not just the schema but the data within the database from one version of the schema to another. So those tools can be handy at dev time though to help create those scripts. And this process, by the way, applies for any kind of database that you've got. In fact, most of these patterns apply to all of the storage techniques that you talked about before. Even if you're doing blob storage and you're going from one folder structure to another, or one different kind of way of tagging to another, like these same patterns apply. If you're using a document database like MongoDB, same kind of thing. You don't worry about schema changes so much, but you kind of do because your app is reading, you're still reading that data and needs to know how to interpret it. And so often when we've worked with document databases, you do end up writing schema migrations too. It's just that they're written in a different language, not in SQL. So the first thing, everything is scripted. The second, those scripts go in source control. That feels like just a generally accepted good practice now. The third is that scripts are sequential. So you can see on our list, essentially everything is just named in a way where you can run them sequentially. They sort alphabetically. The reason this is important is we need to know which scripts we've already run, and we need to run them in a specific order. And as long as we're running the scripts that haven't been run in the same order, we can generally assume they're going to work each time we deploy to a different database for going from dev to test. Once that script has been checked into source control, you don't change it unless the script itself has a bug that prevents it from running. But generally, what's going to happen is, imagine that that you've got a test environment. The minute you've checked something to source control, that script may have run against that test environment. Now you go and make a change to the script. That script isn't going to run in test because it's already run once. And so whatever you've changed about that script won't be running. So be very careful not to change those scripts. There are some circumstances where you change them, but generally keep them immutable. This process works really great too for devs. So if you want every developer to have their own database, instead of everyone having to constantly refresh their database or reset it, a developer gets latest from source control, a new script has been added, they hit F5 to run the app. The tool should figure out what changes need to be made and just runs those couple of scripts. So again, the minute you check something to source control, someone will get latest. They may have already run your script. They're not going to run the changes you make to it. So don't change them. At dev time, think about your migrations up front. This is important because you tend to forget it, especially if it's been a while since you've deployed stuff, or especially if you take a little bit of a lazier approach to your test environment. So, most of the time, we deploy to production, a couple of times a week at the most. It's most of the companies we deal with, they're doing a lot of deployments, but not that many to production. But they're doing a lot of test deployments, and they're doing a lot of dev deployments. Every time a developer commits a change to source control, they're deploying to a dev environment. So you do hundreds of dev and test deployments before you do a production deployment. And so it's good if you can work out that migration logic. How am I going to not just change the schema, but do it in a way that's going to perform on a production-sized data set? If I'm adding a column or something, that's going to lock a really big table to add this thing. If I set a default, that's going to take a really long time to run. Think about those things. Think about how you get the data from, if that table's already got 1,000 records, what do you need to change within those records to make it make sense in the new schema? If you do all of that as you're writing the code that's going to depend on this schema change, you're much more likely to have a successful production deployment. If you've left it a few weeks, you'll struggle to remember the details of exactly what you needed to do during the migration. And if you've written that logic now, this comes to the last point, those migration scripts, the exact same scripts, are running every time you deploy. So when it's the end of a few weeks and it's time to deploy to production, these scripts should have run hundreds of times in your dev and test environment. Well, really, they should run once per environment, but they've been run as part of all of these deployments. So you're going to feel really confident that they're going to work. And that's the main thing that powers automation, right? Is that confidence that something's going to actually work when you go to production. So those are the 6 rules.
Yeah, it's pretty simple from a process perspective, and what we're doing is creating kind of a mathematical proof level of confidence that your database deployment is going to go well. Because even if the people in charge of when to go to production are a little bit timid and don't want to go to production every day or every week, you hear these companies that Netflix and whatnot that are doing 35 deploys a day. You don't have to, because somebody else says, you know what, we're just going to do a monthly or a quarterly production deployment. That's fine. But if you are set up so that you can deploy to your own internal, pre-production environments at any time, then that when it's time for a production deployment, it's going to be a non-issue, and you're not going to have a late night and probably a stressful weekend because you've set yourself up for that. All right, so we've gone through this, but Paul, what about DACPAC or Reggae SQL source control or other compare-based or state-based methods? How do those differ from migration scripts?
Yeah, so it might be worth backing up and just clarifying. Octopus is not a database migration tool. We just handle the automation around the deployment generally. And then when it comes to doing database deployments, you would use some other tool alongside Octopus. And those types of tools fall into 2 camps. There's kind of the script-based approach where we're essentially we care about the difference. What are we changing now? What are we changing now by writing these scripts? The other approach is the state-based approach. So if you use DAC packs in Visual Studio, etc., the way most of them work is that they'll take your entire schema and you commit that to source control in a model of here's what the perfect database looks like. And then at deployment time, you're going to diff whatever database you're deploying to against that perfect model and work out what needs to change to get that database to that stage. The challenge with that is that not all database changes are created equally. So something like adding a new column to a table, those tools can kind of work out the fact this new column is needed. It's not in the source, it's not in the target database, but it's in the model. So we're going to create the column. Sometimes they can suggest intelligent defaults, especially if there's already data in the table. But it gets really messy when you talk about moving stuff between a table. So if you've decided that, we used to have a full name column and now we're doing first name, last name, the migration for that is not just drop the full name column and add 2 new columns. It's going to be to add the 2 new columns and then set their values to some default based on, selecting from the full name, splitting it, and then probably some human intervention for names that don't quite match the pattern that you've come up with. So as a developer, if you're making a change like that, you need to think through this process and understand how you're going to get not just the schema, but the data from one stage to another. A lot of these tools do have a way that you can add that custom logic, but you have to remember how to. And what breaks down for me is that the process on a dev team is that you tend to kind of forget to capture that logic as you're making the changes to the schema. So I prefer the approaches that follow the migration script approach, tools like DBUp. But these tools work as well. I think they're much better if you use them for trying to work out what you've changed, generate a script, then go through that script, check it, make sure it makes sense to you, edit it, make sure it's taking into account there's already data in that database, and then check that into source control and run it as a migration script. Don't just rely on the tools. The promising or the exciting thing about them, right, is if you've got heaps of databases, let's say heaps of customer databases, all with different versions of the schema, they'll just magically look at those and work out what needs to change. The reality is that doesn't tend to work, or you tend to lose a little bit of data in the process. If you follow this migration scripts approach, you can still handle all those customer databases. It's just that for one customer, there'll only be 1 script to run, and for this customer, there'll be 5 scripts to run to get them all up to the same stage when they upgrade.
Yeah, and in practice, there are some cases where you just can't figure out how to do the migration. If you're gonna split a phone number column, or if you're gonna merge 2 columns into one, you have database manipulation, and there's no computer routine that can figure out how you actually wanted to do that little bit of ETL while you were changing your schema. But the script-based approach, it really does always work.
Hey Jeffrey, can you jump back a slide?
Sure thing.
Because someone just asked the question on the chat: how do you baseline these things? And I'll explain what that is. So, you've been going as a dev team for years and years, and we've got these scripts we used. So this is actually from one of our projects, and we used like 4 digits in the numbering thing because we thought there could be a lot of these. So what happens is that you get hundreds of these, right? And a new customer comes along, or you're spinning up a new environment for the first time. And to get the database from completely empty to the latest version of the schema and the data that it needs, you run essentially all of these scripts. It's the same process. What scripts haven't been run? All of them. So work through and start running them. Now, the downside to that is that over time, you've probably changed your mind about a lot of things. So you've added a table, then you've deleted that table, created a new one. So it's going to have to do all that work and create all this stuff and drop it. On the plus side, that's worked, right? Because you've been doing that for years, those exact scripts, so you can guarantee they'll work in production. But it can be slow and it can be time consuming. So what you can do is you can baseline these. So you can essentially say, all right, we're going to have all these scripts, script 0 to 100. And going forward, we're going to make a new version of our script that is just script 0 or script 100, and we're going to delete the last set of them. And we're going to roll all the changes. So this is one big script that creates everything. And different tools have a different approach to this. But generally, what you would do is just tell the tool, hey, all these old scripts we used to have, they've all been run. You are still going to have new customers though, where they can't just run that whole script because they've already got existing data. And so you might need to check, were any of these older scripts run? If they were, don't run this baseline script. So there are techniques for this. That said, this need to baseline things, it feels like something you need as you start to think about this approach. We found in practice, it doesn't actually matter. Octopus itself as a product, we've been going since 2012, so 7 years now, doing this approach, building up these SQL scripts every time we make a release. And we've got, I think it's last count, about 200 of these scripts. And we just run them from start to finish when we set up a new Octopus instance. It doesn't take that long. As your app establishes, you don't tend to add hundreds and hundreds of tables, hundreds and hundreds of procedures, etc. Things start to stabilize over time. It's not that common that we add a new table, for example, in Octopus. So over time, you tend to make less and less of these changes, and that need to baseline isn't actually that as common as you'd think.
I think something to add to that is I have been in projects and been the architect overseeing projects where there did encounter some pressure to do it because the number of scripts grew to be several hundred and started taking a long time. But that system as a whole should not have been that big. That single database as a whole should not have been that big, and it would have definitely fallen into the monolithic classification where that system should, and hence the database should be broken up into a few smaller ones. So that could be a code smell, a database smell, where it's just getting too big. And that's one of the pressures that you could see is, oh gosh, there's way too many scripts, let's baseline. Maybe from an architectural perspective, think, is it appropriate for there to be that many objects in our database? Or, would some segmentation be appropriate? And this is just one of the symptoms that's yelling at us from this side, while some of the other things in our project may be yelling the same thing. Hey, this thing has gotten too big. Pick some segmentation. But we're talking, between 500,000 and 1 million lines of code and a database that goes along with that. So there's tons and tons of applications that you just never get to that point. All right.
So Jeffrey, this question comes up a lot to rollbacks, and I saw some people in the chat already asking about that. How do you deal with rollbacks for database changes?
Yes. Yes, definitely in the Slack channel. Thanks, Chad. It's definitely an important topic. So rollback is a failure. It is. It's a failure of the pipeline. We just failed. Something unexpected went wrong. Nothing in continuous delivery is designed to go backwards. And when you have an automated deployment process that just unexpectedly failed, think about this. Are you really going to trust that same process, any process, to then reliably perform an automated rollback and faithfully then put your system back together the way it should be? Well, most of us would not. So we need to make our deployments a series of very small changes that have been thoroughly tested. And in that way, we're never making big changes, but just many very small changes in sequence. Because once something that's designed to go forward fails, we can't devise an automated process that would somehow analyze the unexpected, but then also reliably go back in time. And again, maybe if you were to add a column, now, yes, there are some migration tools that have migrate up, migrate down, but we believe that those are architecturally flawed. And for some cases where you just added a column, but now maybe we want to remove that column, okay, maybe in some cases you could devise some that would be appropriate. But that only works if it's an immediate case. But what about the merging of two columns, or the splitting of a column, or hey, we're going to move some data and then we're going to drop a column? Well, if we're going to drop and delete some data because we're okay with it, but then the deployment failed, and so now we need to undo it, guess what? We've already deleted data. In the database world, we're not, the rollback strategy when you delete data is to restore from backup. And so unless we're going to somehow figure out some automated routine where every time we drop a column, we're going to somehow do some partial backup or archive away all of that data in the column that we are going to drop just in case it fails, it just breaks down. Architecturally, there's so many exceptions. You cannot make an automated rollback scenario that's going to account for all of your situations. But we can bake quality into the process. So let's just enumerate the various common scenarios. And I already hinted on one of them, but let's just enumerate the scenarios. Splitting a phone number field in a database, we're destroying data. And what we can do is to create a compatibility shim in your database that's in your shared state that's compatible with multiple versions. And then you can redeploy the old version of the application upon failure. So let's take that step by step. So imagine step one, and we're going to, in this case, we're going to split a phone number field from one column into two, and we're going to split out the area code. Okay. So step one, we're going to modify the database schema with the new area code column and the new body of the phone number column, and we're gonna maintain schema compatibility. So we're gonna leave the original field there, and we're gonna ensure schema compatibility, maybe with an update trigger on the database or a compensating action in the data layer of the application. Then we deploy. So no change to our application, but we do have a database schema now that's compatible with the 2B version of the application and the existing version of the application. Then step two, we modify the application with the database layer. And now on our screen in the application, we have phone number and area code split out. Then we deploy the system. Now the application is up to date. Then back on our development workstation, we update the database schema to remove the original or the old column, the original phone number column. And then we deploy again. Now our application and our database are fully upgraded, but we have done it in a way so that if we had failure along the way, we had the ability to correct ourselves, and we didn't get in a burn the ships type of no going back or painting us into a corner. So it's important to have all three types of environments in our pipeline so that your deployment is well practiced before production deployment. If in our TDD environment, we're creating the entire schema from scratch. And so we're going to make sure that the schema is correct. And we're not going to be able to detect some of the data anomalies, but then the next environment is going to have current data, and it would fail if our database schema somehow messed up on having data already there. So deployment failures should be a very rare occasion and thoroughly post-mortemed when they occur, even in a pre-production environment. It's very expensive to design the continuous delivery value stream to permit going backwards at any time on a whim. And we rarely see that capability provide a return on investment. And like Paul mentioned before, there are some tools that are designed to inspect the target database and decide on the fly to do the right thing. But because you're in the middle of a failure scenario, we're in uncharted territory. So we can't rely on a quote down migration or a compare to just automate this and always do the right thing. And invariably, if you rely on that, you're just going to have to manually attend to it, and then we're back to a manual scenario. So design your deployment pipeline to fail on pre-production environments so that the exact set of scripts being run on production has been run on several environments prior many times before. That's really the answer of how to handle a rollback scenario, is to do everything you can to prevent that failure or to force the failure in environments before production.
And Jeffrey, just on that topic, what's your take on some of these migration tools allow you to write not just the migration script to go forward, but the migration script to go backwards as well? DBUp doesn't do this. In DBUp, it's called DBUp because it only goes in one direction. It's not DB down. But other tools do have that sort of, you write the up migration and the down migration Should people be doing that? Do they work? What's your take on it?
Yeah, so Entity Framework Core, the migration tool that goes along with that, it does have uh, it does have an up and a down concept, whereas AliSQL don't, DBEP doesn't, Redgate SQL change automation. I'm trying to remember if they hint at one, but really, they're the the premier ones are designed to go one way. It is a false sense of security to think that there's a way to go backwards in time, because if you look at your DevOps pipeline as a whole, we make a change and we commit something in source control, and then we do a build, and then we package it up, and then we deploy it. And so there's a lot of people who've said the following: if it's not tested, it's broken. And there's also another saying: don't do anything the first time in production. So if you choose from an architectural perspective, uh, automated rollbacks or using the migrate down feature of a particular tool, make sure you're also using a source control technology that has an uncommit function. And I don't know of any source control technology that has an uncommit function. If you look at Git as an example, if you look at Subversion as an example, if you look at TFS version control as an example, they all have where you can commit or check in a change. And if you want to go back in time, if you look at that, what you're actually doing is you are committing a net new change set, which just happens to be the exact opposite of what the original change set was. So if you look at source control technologies, which do faithfully allow you to go back in time, they are made of forward-only changes. And actually a that follows a multiple centuries old convention, which is found in the financial world of accounting, where if you're going to track a ledger of some type of changes to the balance on an account, that general ledger has an ever-growing series of changes or transactions to the account. And if anyone's ever worked in banking, you know that once a transaction happens on an account, it doesn't change. If we found that a teller miscounted something and you have to make an adjustment, you make a new transaction that is an adjustment if you need the balance to change. Once a transaction is added to a ledger on an account in a banking situation or even an accounting, that doesn't change. You add a new transaction, which is a compensating factor. And so the same thing in Git source control, the same thing in database migrations, it all follows the same pattern. Everything is a step forward and is a compensation. Nothing ever tries to rewrite history or go backwards in time. All right. How was that for the long-winded answer, Paul?
That was good. My short answer summary would be those are great, except you've just lost all the data that your users entered, right? You've upgraded, you've gone forward, you've added this table, people are entering stuff. If you try to automatically delete all that, well, guess what? You've just lost a bunch of user data.
Yeah.
The idea that you can predict what's going to go wrong ahead of time and then write a script to compensate for that. If you could have done that, you would have just mitigated the problem going wrong in the first place, right?
That's right. And Bob Walker in the Slack channel just added a great point. If you do an immediate rollback, if you're trying to use one of those strategies, you're still going to lose a tiny bit of data. But what if you find out that you have to roll back the next day? Well, now you've lost a full day's worth of data.
That's right. When we see rollbacks happening with our customers, there's sometimes like an immediate need to roll back or roll forward, deploy a new version or deploy the previous version that was deployed. But that doesn't generally happen. Like sometimes that happens because the deployment itself went wrong. It's almost always because what was deployed was broken. You deployed a new release and it's slower and customers are complaining about it. So that's the reason why you're rolling back. And this kind of thing generally comes up not immediately within seconds after you've deployed, but much later.
All right, so Paul, how do I configure a zero downtime deployment when the database and the application components both need to change?
Yeah, so you kind of hinted at this, right, or answered part of this. So the trick is some changes you make to the database block stuff. They break things. So if you're adding a column to a very large table, or adding an index, not so much adding an index actually, but generally making changes to a very big table can lock that table for a really long time, and apps can't use them. And then there's also changes that you'll make where you're removing something from a schema that the app was depending on, and the app is running. So the app is issuing a select statement from a table, it's getting some results back, another customer comes along, it issues another select, it gets some results, and suddenly you change the schema underneath and the app stops working. Now, of course, you can deploy the new version of the app, but a customer's going to come along and select, and it won't understand, the select statement won't work against that table, and it won't work, and then you do your schema migration, and then it will work. So this is the fundamental problem you have to solve. You've got an old version of the app and the new version of the app potentially reading from an old version of the schema or a new version of the schema. And the trick is to make those things compatible at least to the previous version. So, for example, if we're doing a change where we're saying we're going to let's go back to this full name to first name last name business. We're going to first add the two new columns that we need, first name, last name. We're going to copy the values from the full name, split them, do our migration on them. And now we've got the two new values, but we leave the old field in place. While the app is running, it can keep selecting from the table, selecting the full name column back and working with that. And then you deploy the new version of the app, and it's just going to start reading from the two new columns that you've added and not reading from the full name column. Both versions of the app can still run against that version of the schema. A day later, a week later, you do another deployment where you remove that field now that no version of the app is using it. So this is essentially the way that we go about zero downtime deployments, trying to find a way to always be compatible with the currently running version of the app and the next version of the app, or making our schema compatible with both. But there are situations where that's not always possible, but there's generally always a workaround. So if we are adding, doing something where we have to take an entire table offline, you can do things like take a copy of the table, add the new schema, etc., insert the data, like select from the old table into the new one, have the app read from the new one with the new schema, and then at some point drop the old table. These things are hard. Like zero downtime deployments there's not a checkbox, right, that you just tick to say make this thing zero downtime. It can be for web apps and other things. There's all kinds of tricks you can use around. You deploy the new version of the app and you point the load balancer from the old one to the new one. Zero downtime deployments can work fairly easily there. When it comes to the database, your entire process changes. The way you think about doing your migrations changes, and that adds a certain cost. What we typically tend to see is customers will kind of have two versions of their deployment scheme. So they'll essentially have the simple one when they're just deploying changes to the web app, and then they'll have the bigger one where they take the app offline for a little while they do a database migration, and they just don't do those as frequently, or they try to avoid them. But hopefully that
Yep.
kind of explains the process.
Yeah, a lot of similarities there.
So what does all of this look like? We've talked about migration scripts. We talked about this kind of process. You have a demo for us?
Absolutely. I mean, what demo? What? No. So here we go. Let's go ahead and let's look at Clear Measure Bootcamp, which is a open source. It's an open source application. Just so you can see what the Git repository structure looks like, and up the top we have a build script and a helper, and I've already run that. It takes 2+ minutes to run, but just from the developer experience, this is what is running on the developer workstation. And so if I just scroll up a little bit, because right here you can see that let's see, data loader, how many tests succeeded. Okay, you can see all these executing 001 SQL. These are all scripts that I'll show you in a minute, but we have essentially 16 SQL files that executed, and now we've rebuilt. Okay, so that's the build script. But let me pull over Visual Studio, because that's what we're all working in. And by the way, if y'all didn't notice, Visual Studio 2019 launched, so y'all can kind of upgrade to that. But this is Visual Studio 2017. This is .NET Framework 4.6.2, and when we get .NET Framework 4.6.2 in Visual Studio, that's compatible with .NET Standard 2. So this application happens to be using Entity Framework Core 2 as an object relational mapper, and it works fine in .NET Framework. So let me show you real briefly how our application is configured from a project perspective. We have a database project, which this happens to be using AliasQL, but if it was Roundhouse or DBUp, it'd be the same setup. And we have a directory with those 16 SQL files. And if I just look at one of them, one of the early ones, guess what? We're creating a brand new table in this particular one. One of the latest ones, all we're doing is altering a table and adding a middle name column. And if we look at our schema, we can see that the employee table has these columns, okay? So we want an employee to have a nickname. What does it look like from a developer experience to have a nickname? Okay. Well, let's go over to that. Let's go to the Solution Explorer, and we always want to be doing test-driven development. So let's go to our integration tests where our data access code is there, and I've kind of seeded this. So we have a test class, which is employee mapping tester, that just makes sure our object relational mapping code in our data layer is working properly. And I'm going to augment one of the tests that is just making sure that all of the columns are hooked up properly, and that if I persisted, all the columns come back. So we need a nickname column. Well, obviously, this test is red because it won't even compile. So let's just go ahead, and I happen to love using ReSharper, so I can code forward. And I just created the nickname column. Yep, that works great. Nickname's there with an auto property. Now it compiles. So let's just run this test, and it should still be red because I haven't done anything to the database. So how could we possibly round trip to the database properly with a nickname column? Because my assert is not going to work on line 37 because there's no way that I could be persisting a nickname column. So I'm rerunning this test right here. You can see it running. And when it comes back, it should fail because, yep, there we go. One or more tests. Let's see, which test is it? Should persist. Failed because, and it's going to point us right to it, invalid column name nickname. Fantastic. So if it's invalid column name, then let's go ahead and now make it green. So in my database, I could come over to here, and in my SQL Server Explorer, I could go ahead and add a column right here. But what I'm actually going to do, because I'm using database migrations, is I'm going to add a script. And so I'm going to add a script, and I'm going to add a nickname column. Now, it just happens to be pretty similar to this one. So you always want to take shortcuts, right? So let me just make a copy of this, and let me rename what this is. And I'm going to name it number 17, and it's going to be employee nickname and .SQL. It's going to order it, and now I'm in here, and so instead of middle name, it's going to be nickname, and I can leave that there, and this was generated by a previous tool. I'll just get rid of that. So alter table employee nickname, let's go ahead and save that. And because I'm using Entity Framework Core, I know that I have a mapping file here. And if I'm going to add this, I like to be explicit in this particular application. It's not necessarily required because Entity Framework Core sort of guesses, but if you want to control the links and everything, then you can make it required. I don't want to make this one required because all my other tests are going to fail if I did. So let me save that. Let me go back to my employee mapping tester, and let's see if I need to do anything else in order to make this succeed. Now, of course, if you're watching me closely, you're going to say, wait a minute, it's actually not in the database. You just created the script. You didn't actually change your database, and you'd be very astute for thinking that. So I just wanted to do one more round and show that we actually haven't modified our database. So it'll fail, and there we go. The column is still not there. So if with this as my startup project, I hit Control F5 just because this is a little bit of helper. If I want to rebuild my database, I do it here really quickly. I could also rerun my private build, and notice script number 17 executed. So great, that was perfect. I can close that and let me rerun my integration test here and see what happens. And if I've done everything necessary in order to make my nickname column persist to my database table and then be retrievable, it's green, and it's green. And now, because I have a new file, and if I want to just do a spot check over here and refresh this view just to see how my schema came about, I can do that. And tables, looky here at employee columns, and now I have my nickname column. So that's perfect. And when I go and commit this to my team, to my branch, and another one of my teammates does a git pull, they're going to get this new file. And when they run the private build, their local database is going to be created with the nickname file. Now, one more thing before I end this demo. This is also set up with Redgate SQL change automation, because that's a commercial tool. And when setting it up, this application has a lot of history. There's 16 different files just in a open source sample application. But Redgate SQL change automation was created by baselining all of those SQL scripts in, and it was scripted out from scratch. And so all of those are in the same file. So you can baseline it, but you just can't deploy to any environment which has an interim state. So that's what that looks like. That's what the development experience is. And it's pretty sweet. And it makes it super, super simple. Is there anything you would add to that, Paul?
No, that's beautiful. Very nice. So, somebody asked what scripts you have in the create folder or the update folder.
Oh, sure. So with DBUp Roundhouse or AliasQL, if you go to an existing database that has not had any migrations, you're going to want to script out what is there currently and put it in the create folder, so that when you do the update routine or the update command against a database, it doesn't even worry about the scripts that are in the create folder, because it doesn't expect to see those scripts in the history table. If you start a new database from scratch, you'll never have any scripts in a create folder or an initial folder. But if you do start a database that's had a lot of history before, then you'll have the initial scripting of the schema in a folder like that.
So this is like someone's got an existing database. It's been around for years. It's got all this schema to it. And this is the first time anyone's done any kind of migration scripts for it. They take that script, chuck it in here. And then if you are setting up a new dev environment or something, you can just run that script to get up to the same state.
That's right. And when you create it, it runs all the scripts in create and in update in that order. Mm-hmm. And all in the different tools are nuanced, but they all have similar concepts. One thing with the development, I know this was about the development experience, but on the continuous integration server, when you do your integration build and your packaging, you want to take care that you have a package dedicated to that SQL Server database schema, and whatever project in Visual Studio you keep your scripts in, that all of those scripts do get packaged in your database package, and that the build number is stamped there, so that when you're an Octopus deploy, you have a package that is dedicated to that database schema and ready to go. And I think I've already shown this for how Octopus Deploy grabs the package and then deploys. So I know we went over time. I think we're 9 minutes longer this time, Paul.
That's okay. It was great content. If you have any other questions, stick around to the Slack channel. Our team will be around for a while. We'll answer any more questions. It looks like there's still some discussion about zero downtime deployments. I think we'll try and handle that in the chat. If you have any other questions, feel free to drop them in now. Otherwise, thanks very much, everybody.
And we do have a free offer for webinar attendees. If you'd like, uh, if you have implemented Octopus Deploy in any way, we'd be happy to provide a free 30-point inspection of your existing Octopus Deploy pipeline in your environment, so that we can tell you, hey, great, you implemented exactly right. You're gonna do well, or give you some pointers for how we would recommend implementing it differently. And if you have not implemented Octopus Deploy, we would be happy to help you out with that, even if it's just giving you some verbal pointers, or if it's for coming alongside your team and helping you really get that full automation end to end going, so that you can be successful with your automated DevOps process. But we thank you for your time, man, Paul. I had a blast. How about you?
Yeah, very good. Very good. All right. Thanks, everybody. Have a great day.
All right. Bye-bye.